In the name of God, the most merciful, may the peace be upon you and God's mercy and blessings. This is the second part of the lecture on how to get the X max, or the maximum horizontal distance for maximum deflection for a beam, which is acted upon by a triangular load based on the Newton-Raphson method. The first slide includes the value of the slope of theta for the left as well as the right support for a simply supported beam under triangular load of maximum intensity of W naught. The span of the beam is L. We can see that theta 1 value equals minus 7 W naught L raised to the power of 3 divided by 360 EI, while the theta 2, or the value of the slope for the right support of the elastic curve, will be equal to W naught by L raised to the power of 3 divided by 45 EI. The elastic curve equation, the small v, equals minus W naught x divided by 360 EIL multiplied by 3 x to the 4 minus 10 by L square x square plus 7 L to the 4. The maximum deflection value is given as equal to minus 0.00652 by W naught L to the 4 divided by EI. It is located at x equals to 0.5193 L, measured from the left support. We can see here at the left support we have the two axes, x and the small v axis. These values, whether theta or deflection or elastic curve, are driven from Professor Hebler's book, Mechanics of Materials. Now we will move to the next slide. This is a simply supported beam. The span is 6 meters, L equals to 6 meters, and the maximum intensity of the triangular load given as 2 kilonewton per meter. The EI value equals 8 multiplied by 10 to the 4 kilonewton meter square. I have listed all the three equations that we are going to need in our estimation. The first equation is for y double dash. Y double dash is nothing but the moment divided by EI. We have y double dash equals 1 over EI multiplied by W naught Lx over 6 minus W naught x cubed divided by 6L. X is measured from the left support. Again, here is y double dash, and this is the curvature represented by y double dash. At A and B, the values of the curvature equals 0, since there is no moment at these 2 points. The second equation is y dash, which is equal to 1 over EI multiplied by W naught L x squared divided by 12 minus W naught x to the 4 divided by 24L minus W naught L cubed divided by 360. While for the third equation, y equals 1 over EI multiplied by W naught L x cubed divided by 36 minus W naught x to the 5 divided by 120L minus 7 over 360 multiplied by W naught L cubed by 6. These are the two curves. This curve represents the values of the theta A and theta B, starting from negative going back to positive. And the third curve is the one we are looking for. This is a deflection for which we have a maximum deflection at x equal to 0.51 0.93L. For a span of 6 meters, we expect to have the X maximum distance equals to 3.1158. with a value of 0.00652 W naught L to the 4 divided by EI. We want to utilize the Newton-Raphson method to get the location or the X max value numerically. We will move to the next slide. In the next slide, we can see the Newton-Raphson method for X sub I equal to X naught minus f of X naught divided by f dash of X naught. But this equation is suitable when the f of X intersects with the X. So we have a root in the X. But in our condition, the only function that intersects with X and give us the value of 0 is the Y dash curve. So in order to utilize the Newton-Raphson method, we are going to make a modification, and the equation will be represented as X sub I equal to X naught minus f dash of X naught divided by f double dash of X naught. So we will be concerning with the Y dash. We will select the starting point of X naught equal to 2. And in order to get or to apply in this equation, we need to find out the f dash of X naught equal to 2 and f double dash X naught equal to 2. We are going to apply for the two equations. The first equation is Y dash, which is equals to 1 over EI multiplied by W naught L X squared divided by 12 minus W naught X to the 4 divided by 24L minus 7 over 360 all multiplied by W naught L cubed. We have W naught, the maximum value of the triangular load, equals to 2 kilonewton per meter. The L equals to 6 meter. So f dash of X naught equals to 2, which is our starting point, will be equal to 1 over EI, or 1 over 8 by 10 to the 4, open one big bracket, 2 multiplied by 6 multiplied by 2 raised to the power of 2 divided by 12, minus 2 by 2 to the power of 4 divided by 24 by 6, minus 7 over 360, W, which is 2 multiplied by 6 to the power of 3. This will give us minus 5.777 by 10 to the minus 5. While for the equation of Y double dash, it will be equal to 1 over EI minus W naught X cubed divided by 6L. F double dash of 2 equals 1 over 8 multiplied by 10 to the 4, open one bracket, 2 by 6 by 2 divided by 6 minus 2 by 2 raised to the power of 3 divided by 36. F double dash of 2 will be equal to plus 4.444 multiplied by 10 to the power of minus 5. In order to apply for the equation, now the equation have been modified for the Newton-Raphson method. It will be xi equals to x naught minus f dash of x over f double dash of x. So x1 equals to 2 minus, we take this value, minus 5.77, 10 to the minus 5. We divide it by the f double dash of 2, which has a value of plus 4.444, 10 to the power of minus 5. We have here minus multiplied by minus divided by positive. Finally, the x1 value will be equal to 3.2999, which can be approximated to 330. So our starting point x naught equals to 2 will give us 3.3 meters for the first iteration. From the previous calculation, we have x1 value equals to 3.3 Again, we are going to get the value of f dash of x for the value of x equal to 3.3. We are going to apply for the first equation f dash of 3.3 equals 1 over 8 multiplied by 10 to the 4, open one big bracket, 2 multiplied by 6 by 3.3 raised to the power of 2 divided by 12, minus 2 by 3.3 raised to the power of 4 divided by 24 by 6, minus 7 divided by 360 multiplied by 2 by 6 to the power of 3. The value is positive value equals 1.0536 multiplied by 10 to the minus 5. While for the y double dash value of 3.3, it will be equal to 1 divided by 8 multiplied by 10 to the 4, open one bracket, 2 by 6 by 3.3 divided by 6, minus 2 by 3.3 raised to the power 3 divided by 36. The f double dash of 3.3 will give us positive value of 5.7543 multiplied by 10 to the minus 5. But this will be x2, so x2 equal to 3.3 minus the y dash value, which is 1.0536 by 10 to the minus 5 divided by y double dash value, which is plus 5.7543 multiplied by 10 to the minus 5. This positive, so the value will be deducted from the 3.3 and will be equal to 3.116902. In the next slide, there is a tabulated graph. This is the Excel sheet for which there is one column for the distance x based on the different values from 0 to 6 by meter, and the second column represents the curvature value y double dash starting from 0 ending to 0 for x equal to 0 to x equal to 6. The last column is for the slope in rod for the x equal to 0 is equals to minus 0.00105, which is represented here at x equal to 0 minus, while the other value for the x equal to 6 is represented by a positive value of 0.00120. We have started, our starting point was x naught equal to 2. When we get the value of f dash, we have negative value of 5.778 multiplied by 10 to the minus 5, as shown here in the table and on the graph. We take the slope, we hit the x-axis at 3.3 meter based on our calculation. Then we come up and get the value of the 3.3. We get the slope and we hit the curve. So our starting was from 2, leads us to 3.3. Then finally we have 3.1159 meter. In the next slide, I have used the Excel sheet, which we are going to see how easy it can be used to get the values. The first column is x. The second column is for f dash of x. The third column is for f double dash of x. And the fourth column is f dash of x divided by f double dash of x. I'm going to multiply this by minus. Then we will subtract this. If it is plus, it will be added to 2. If it is minus, it will be subtracted, as we are going to see. When we have x equal to 2, we have f dash x over f double dash of x naught is minus 1.3. We multiply by minus, so we get 1.3 added to 2 will be equal to 3.3 meter. Then we put this value here as the value of x. We get the f dash of x and f double dash of x. We divide f dash of x equal to 3.3 over f double dash of x equal to 3.3. We get positive value. We multiply it by minus. So we are going to deduct 3.3 minus 0.1831, it will give us 3.11690. We plug in as x equal to 3.1169029 in the equation of Newton-Raphson. We estimate the f dash of x and also the f double dash of x for this value. We divide f dash of x over the f double dash of x, we get 0.00092513. We multiply it by -1. So we are going to subtract the value of x will be 3.11597. We plug it again. We estimate f dash of x and f double dash of x. It will give us two very small value of -4 multiplied to the 10 of -8. The final value we are talking about an x is 3.115977, which is very close to 3.1158 estimated by the analytic method. Suppose somebody would like to take starting point with a different value. So I have prepared two starting points with different values than 2. The first point will be x naught equal to 3. The same technique will be used. We will put the value of x equal to 3 and find the f dash of x equal to 3 and f double dash. So for x equal to 3, the f dash of x equal to -6.5625 minus 0.6, and the f double dash of x, as we can see, is 0.0005625. We divide and then we multiply by -1. This is a positive value. It will be added to the 3. So we have 3.11667. We plug it and put it here, and again estimate the value of f dash of x of 3.116667, and as well as the f double dash of x. We divide f dash of x over f dash double dash of x. We get a positive value multiplied by -1. It will become -0.007. Will be added to 3.11667. Will give us 3.59778. We put it again, and same process will be repeated. For the last time, we will find that the value is coming to 3.115977. If we use x naught as equal to 4, and we start to make an iteration table based on Newton-Raphson method. Our starting point 4, we estimate f dash of x and f double dash of x. We divide f dash of x over f double dash of x. It will give us plus 0.91 multiplied by -1 and add to the 4. It will give us 3.09. It is reduced because we have a minus. We put 309 here. We estimate the f dash value of x equal to 3.09 and f double dash of x equal to 3.09. Here is the value for f dash of x, and this is the value of f double dash of x. We divide this over this, we have a negative, but again we will multiply by minus. It will become positive value. We add it to 309. We have 3.1160074. We use it as a new value, etc. We continue, and we will find that the value, final value is 3.1159, which is very close. We will come to our last slide. This is again the graph of the slope, and this is the Newton-Raphson method after adaptation. When we start by 3 and take the slope, it will lead us to 3.1169. We get the value and we repeat again the slope. We hit the x-axis and come back again to get the value of f dash. So we have 3.11597. This is the 3 value. When we have x equal to 3, this is the f dash value. and this f double dash value. This is when we multiply by -1, it will become positive. That's why the 3 is increased. It will lead us to 3.11597. While when we start by 4, we started here by 4, this is a positive value. We take the slope, we hit the x-axis, and coming up, it will be reduced. This is the point of 0 slope, or the point of maximum deflection. So from 4, it will come to 3.09, as approaching to this point, 3.1159 meter. Thus, we have come to the end of our video. Thanks a lot. God bless you all, and goodbye.